Students, we are given a list of questions. We are expected to find which of the following equations are quadratic. Now, you have to know this important point. For any equation to be quadratic, it should be of the form ax squared positive bx positive c equal to 0. Now, a, b, and c are element of any real number. Okay, so they can be any quantities for that matter, which are contained in R. The most important thing is the degree of x, the highest degree of x should be always 2. Remember that. So this is a very important rule that you have to know. Now, having said that, the first question is given to be as 2x positive 1 raised to the power 2 is equal to 3 times of x negative 7. They are asking if this is a quadratic. Expand this. This is going to be 2x raised to the power 2 positive 2 times 2x times 1 positive 1 is equal to 3 times x negative 21. This is 4x squared. 2 times 2x is 4x positive 1 is equal to 3x negative 21. Clearly you can conclude from here that this is a quadratic equation, but just for the sake of completion I will complete this. This is 4x squared positive 4x negative 3x positive 1 positive 21 equal to 0, which is rewritten as 4x squared positive x positive 22 is equal to 0. So this is the quadratic equation, right? So you can maybe state that this is a quadratic equation. QE stands for quadratic equation. Now sometimes they may ask you find the value of A, find the value of B, find the value of C. So if they were to ask you that, now this is of the form ax squared positive bx positive c equal to 0. So clearly A value will be 4, B's value will be 1, and constant C value is equal to 22. Now if they ask you further down to find the value of A, B, C, then expanding this equation and simplifying it will be of much use to you. So let's go to question number 2. Now question number 2 is given to be as 3x squared negative 18x negative equal to negative 2 of 7 positive x. If you expand this, this is 3x squared negative 18x is equal to negative 14 negative 2x. I can rewrite it as ax squared negative 18x. Bring this 2x to the left, it's positive 2x positive 14 is equal to 0. From here it's 3x squared negative 16x positive 14 is equal to 0. If you can clearly see the degree of x, the highest degree of x is 2. So this means the given equation is a quadratic equation. Okay, so let's go on to question number 3. Now question number 3 is given to be as x negative 2 times 2x positive 1 is equal to 2x negative 1 times x positive 1. So expand it. X times 2x will give you 2x squared. X times 1 would give you x. Negative 2 times 2x would give you negative 4x. Negative 2 times 1 would give you negative 2. 2x times x would give you 2x squared. 2x times 1 would give you positive 2x. Negative 1 times x would give you negative x. Negative 1 times positive 1 would give you negative 1. So this is simplified as follows. This is going to be 2x squared. Negative x added with negative 4x would give you negative 3x, negative 2. Bring all these quantities to the left. This would be negative 2x squared. This is going to be x, so when you move it out to the left side, it's going to be negative x. This will become positive 1 is equal to 0. Now I can clearly cancel positive 2x squared, negative 2x squared. I can add negative 3x with negative x, that's going to be negative 4x. And negative 2 with positive 1 would give me negative 1 is equal to 0. Now the degree of x here is 1. Okay, now since the degree, okay, the highest degree of x equals 1, this implies this equation is not a quadratic equation. Okay, so this is the next question, students. So what you need to do is you got to expand this entire thing. This is x squared negative 2x positive 1 is equal to x squared negative 4x positive 4. You bring all these terms on the left, so this is going to be x squared negative 2x positive 1 negative x squared positive 4x negative 4 equal to 0. Now clearly you can see that the positive x squared negative x squared can be cancelled. Negative 2x can be added with positive 4x, that's going to be positive 2x. And positive 1 added with negative 4 will give you negative 3 equal to 0. Of course, they are not asking us to find the value of x, but clearly we see that the degree, the highest degree of x equals 1. This implies this is not a quadratic equation. Okay, so that completes the result for this question. Students, this is the next question. We are given 8x cubed negative 2x squared positive 5 is equal to 2x negative 3 raised to the power 2. So this is what we are being given. So what we need to do is expand this. We get 8x cubed negative 2x squared positive 5. On the right side, this is going to be 2x raised to the power 2 negative 2 times 2x times 3 positive 3 squared. This is going to be 4x squared. 2 times 2x is 4x. 4 times 3 is 12x positive 9. On the left, I got 8x cubed negative 2x squared positive 5. Rewriting, moving everything to the left, I would get 8x cubed negative 2x squared positive 5 negative 4x squared positive 12x negative 9 equal to 0. Further, this is going to be 8x cubed negative 2x squared added with negative 4x squared would give me negative 6x squared, followed by positive 12x, and then 5 added with negative 9 will give you negative 4 is equal to 0. Now if you were to see, the degree of this is 3. You can write it down. The highest degree of the equation equals 3. So this implies this is not a quadratic equation. So that completes the solution for this question. Students, we are given next question. X times of x negative 5 raised to the power 2 positive 5x squared positive 5x is equal to x of x squared negative 2. We expected to find if this is a quadratic equation or not. Now if you were to expand this, this is going to be x squared negative 10x positive 25, and this is going to be 5x squared positive 5x is equal to x to the power 3 negative 2 times x. I can expand this again. This is going to be x cubed negative 10 times x squared positive 25x positive 5x squared positive 5x is equal to x cubed negative 2x. I can rewrite this as x cubed negative 10x squared added with positive 5x squared would give me negative 5x squared. 25x added with 5x would give me 30x is equal to x to the power 3 negative 2x. I would be bringing all these terms to the left. When I do that, I would get x cubed negative 5x squared positive 30x negative x cubed positive 2x is equal to 0. Now, x cubed positive will be cancelled with the negative x cubed. So that would mean I now have negative 5x squared and 30x added with 2x would be giving me 32x is equal to 0. Now, you don't need to change any signs unless or until they are asking anything in specific. But what you need to do is to make this observation. Now, clearly, the degree of x, in fact, the highest degree, okay, you can write it down to be more specific. The highest degree of x equals 2. This implies the given equation is a quadratic equation. So this completes the solution for this question. Students were given this question: determine if x equals 1 over 2 is a root of 2x squared negative 5x positive 2 is equal to 0. Now, if x is equal to 1 over 2 is a root, say let us assume f of x, let f of x be equal to 2x squared negative 5x positive 2. Now, if x is equal to 1 over 2 is a root of f of x, then f of 1 over 2 would be equal to 0. So this is a very important condition you should know, okay, for any value to become a root of the function. Now, substituting x equal to 1 over 2 in, say for example, I take this as 1, we get, so what do we get? F of 1 over 2 is equal to 2 times 1 over 2 raised to the power 2, negative 5 of 1 over 2 positive 2. This is 2 of 1 over 4 negative 5 of 2 positive 2, which can be rewritten. Now 2 divides 4 2 times, so you have 1 over 2 negative 5 over 2 positive 2. Now if I were to take the LCM, let me show it here. Now you have 1 over 2 negative 5 over 2. I take the LCM as 2. So what do I get? I get 1 negative 5, which is going to be negative 4 divided by 2, which will give me a negative 2 value there. So when I simplify these two compounds, I get negative 2. That has to be added with positive 2. So I get the outcome as 0. Right? So negative 2 added with positive 2 gives me 0. So what is the inference? What is the inference? This implies x is equal to 1 over 2 is a root of the function f of x. Okay, so this completes the solution for this question. So we are given this question: is x equal to negative 2 a solution of x squared negative 5x positive 8 is equal to 0? You can also do this question in this following fashion. Given x squared negative 5x positive 8 is equal to 0. If x equal to negative 2 is a solution of, if I were to take this as 1, then it should satisfy the equation. So this is an important step to write. So this means if I substitute x equals negative 2, I should be getting the value 0. So let me see if I'm able to get the value 0. So this is equal to negative 2 squared, negative 5 of negative 2, positive 8. So this is going to give me 4, 5 times 2, positive 10, and positive 8, which is equal to 14, positive 8, which is 22, which is not equal to 0. So this implies x equal to negative 2 is not a solution of x squared negative 5x positive 8. Okay, that completes the result for this question. Students, we are given a list of quadratic equations. We have to use the technique of factorization. Now you have to know that there are 4 ways to solve a quadratic equation. 4 ways to solve any quadratic equation. And those 4 ways, the first way is called as factorization technique. Okay, factorization method is number 1. Number 2 is using the formula, quadratic formula method. This is the second way. The third way is called the completing the square. Completing the square. This is the third way, completing the square. Now the fourth way is graphical method. Okay, by graphical way or graphical method, you can solve a quadratic equation. But in this class, we will use the concept or the technique provided by factorization to solve these quadratic equations. So let us get going. The first question is given to be as 3x squared is equal to 9x. To solve this, move 9x to the left. That would give you 3x squared negative 9x is equal to 0. Now you can take 3x out and that would give you x negative 3 equal to 0. Now you have to know from algebra, if AB is equal to 0, then A is equal to 0 or B is equal to 0. So from this, you can clearly write that either 3x is equal to 0, so which means x is equal to 0 will be a root, or the statement is important, this word is important, x negative 3 is equal to 0. From here you get x is equal to 3. So you have got the solution as x is equal to 0, comma x is equal to 3 to be the roots or the zeros or the values that satisfy this equation. So this is the solution for question number 1. Now question number 2. Now we are given x negative 5 times 2x plus 1 is equal to 0. Very important part you have to know here. This product is equated to 0. Now we know that. What do we know? WKT stands for we know that. We know that if AB is equal to 0, then A is equal to 0 or B is equal to 0. So using that concept, we would get x negative 5 is equal to 0. From here, x is equal to 5. This is one value for x. Or 2x positive 1 is equal to 0. From here, 2x is equal to negative 1. So x is equal to negative 1 over 2. So therefore, the values of x are, start with the smallest value, negative 1 over 2, and then place the bigger value 5. So this would be the solution to the question. Okay, so question number 3. So what is question number 3? Now question number 3 is given as x of 2x positive 1 is equal to 9. Now remember, this is 9, but this is 0. That's why I can apply the law. In this case, I cannot apply this law. Remember that. What I should do, I should expand. So expanding, what do we get? So when you expand this, expanding, we get, so 2x times x would give you 2x squared. X times 1 would give you positive x is equal to 9. Now move the 9 down. So this is equal to 0. So this is what you're getting. So the question now is to simplify or to solve this. So how are you going to solve it? Now if you see this equation, it cannot be factorized because of the presence of the number 9. So you can clearly say by factorization we cannot achieve the result, or you can simply conclude that this cannot be factorized. Okay, so that is why when I started I said there are 4 ways to solve a quadratic equation. So this can be solved using the formula method, okay, the quadratic formula method, which I will show you in the later classes. But instead of 9, if we were to be given say 6, suppose you have 2x squared positive x, instead of 9, if you would have add 6, and that is equated to 0, then you can factorize, because you can rewrite this as 2x squared positive x can be rewritten as 4x negative 3x followed by negative 6 equal to 0. Now these two can be clubbed. I'm using the space here. I can take 2x out, and that would give me x positive 2 here. I can take negative 3 out, and that would give me x positive 2 equal to 0. Negative 3 times x would give me negative 3x. Negative 3 times 2 would give me negative 6. So from here I can clearly take x positive 2 out and take 2x negative 3 out and equate it to 0. So from here x positive 2 is equal to 0, or 2x negative 3 is equal to 0. So from here 2x is equal to 3 and x is 3 over 2. So this is a solution. And from here x is equal to negative 2 is the solution. So because of the presence of the number 9, we cannot achieve the factorization for this equation. However, if 9 is replaced with 6, then factorization is possible for this particular question. Student, this question can be easily factorized by the following way. I can rewrite this x squared positive 3x negative 4 as x positive 4 times x negative 1 is equal to 0. Now the best way to do that, draw a line like this. Negative 4 times the coefficient of x squared is 1, so that's going to be negative 4. So place negative 4 here. Draw a line and place the coefficient of x down here. Now you need to find two numbers to place them here, so that the product of those two numbers, when you multiply those two numbers, you're getting negative 4. But when you add those two numbers, you're getting positive 3. Now, if I were to place 4 here and negative 1 here, 4 added with negative 1 would give me 3. And 4 multiplied with negative 1 would give me negative 4. So that is why I'm writing it as x positive 4 times x negative 1 is equal to 0. So this is one of the ways by which you can adopt the technique of factorization. So clearly from here I can rewrite this as x positive 4 is equal to 0, or x negative 1 is equal to 0. From here x is equal to negative 4, or x is equal to positive 1. So therefore the values of x are negative 4 comma positive 1. So that completes the solution for this question. Students, we are given this next question. X of 3x positive 5 is equal to 2. We are expected to find the values of x. So what I'm going to do, I'm going to multiply x inside. That would give me 3 times x squared positive 5x, and bring the 2 to the left. That's going to be negative 2 is equal to 0. And I'm going to rewrite 5x so that I can use this 3x as a factor. That is only possible if I have a 6x and remove x from it. So 6x negative x gives me 5x, but at the same time I can club these two together and take 3x out. Now bring the negative 2 down, so that's going to be 3x squared positive 6x negative x negative 2 is equal to 0. Now club these two together and these two together and rewrite them as, I can take 3x as a factor. That would mean I got x positive 2. 3x times x gives me 3x squared. 3x times 2 gives me 6x. Now to get x positive 2 on the other side also, I need to have negative 1 as a factor. When I do that, this is going to be x followed by positive 2. Negative 1 times x gives me negative x. Negative 1 times positive 2 gives me negative 2. This is equal to 0. So clearly x positive 2 is a factor. It can be taken out. That means I've got 3x negative 1. That has to be equated to 0. Now clearly from here x positive 2 is equal to 0, or 3x negative 1 is equal to 0. From this I can reduce the values of x to be as negative 2. And from here I can rewrite 3x negative 1 equal to 0 as 3x is equal to 1, and then x is equal to 1 over 3. This is what I've got. So you can sum up the result. So therefore x is equal to, write the smallest value, negative 2 followed by 1 over 3. So this is my solution to this question. So this completes our factorization question, students. So let's move on to the next section. Students, in this topic we are expected to understand the nature of roots and solve using the concepts of nature of roots. And to start off, foremost you have to know the quadratic formula. So suppose you are given ax squared positive bx positive c equal to 0. This is a quadratic equation. The formula is given to be as x is equal to negative b plus or minus square root of b squared negative 4ac divided by 2 times a. Now it's very important that you stretch the square root sign. Okay, don't leave it off. If you leave it off till here, it is marked incorrect. So the root, the radical sign which you call it, has to stretch so that it covers the c also. Next point. Now what you see within this radical sign, this is a radical sign, the square root sign, and this radicand is b squared negative 4ac. This is called as the discriminant. Okay. Now depending upon the value that the discriminant takes, the nature of the roots will change. So we are going to look into that. So how do we know the value? Now if, let me use the space here. Now if b squared negative 4ac, if it is equal to 0, then I'm writing the statement, the roots are real and equal. So this is the case. If b squared negative 4ac is equal to 0. Next condition, condition number 2, if b squared negative 4ac, if it is greater than 0, then what happens? You get the roots to be, the roots are real and unequal. Have it in mind. Okay, the roots are real and unequal. So condition number 3, if b squared negative 4ac, if it is less than 0, then what happens? Condition number 3, the roots are undefined. You have to use the word undefined. Okay, this is the best way to write, undefined. Sometimes they say the roots are imaginary. Some books they use this word imaginary, imaginary. This is also okay. So having given you this concept, this is an important concept. You should know this by heart. This concept is critical. Having given you this concept, let us proceed to do these questions. So the first question, we are given 5x squared negative 8x positive 3 is equal to 0. Now just for the sake of convenience, write the quadratic equation, ax squared positive bx positive c equal to 0 below that. Then from here we know. So what do we know? We know that the value of a is 5, the value of b is negative 8, and the value of c is 3, positive 3. So just to make the entire process a little bit principled or a little bit organized. Now we need to find the discriminant which is given as, you have to know the spelling for that, discriminant. Okay, discriminant. Some of the books will just write it as d. The discriminant d is equal to b squared negative 4ac, which is equal to negative 8 squared, negative 4 times, 5 times, 3 times. 8 8s are 64. 4 times 5, 20. 20 times 3 is 60. 4 negative 60. In other words, 64 negative 60 would give me 4, which is clearly greater than 0. Right? So this means since d is greater than 0, the roots are real and unequal. That's important. Okay, this is for the first question. Now the second question is given to be as 5x squared positive 12x positive 1 is equal to 0. So from here we can write down the quadratic equation ax squared positive bx positive c equal to 0. My a is 5, my b is 12, my c is 1. The discriminant d is equal to b squared negative 4ac, which is 12 squared negative 4 times a is 5, c is 1. 12 squared is 144, 4 times 5 is 20, and this is going to give me 124, which is greater than 0. So this means since d is greater than 0, the roots are real and unequal. So you need to complete that statement. Now question number 3. What have we got? Question number 3 is given as 3 times x squared negative 3x positive 4 is equal to 0. So you write down the quadratic equation ax squared positive bx positive c is equal to 0. A is equal to 3, b is equal to negative 3, c is equal to 4. The discriminant d is given as b squared negative 4ac, which means negative 3 squared negative 4 times a times c times 9. Negative 4 times 3 is 12, 12 times 4 is 48. Now this is going to give me negative 39, right, which is clearly less than 0. Now since d is less than 0, which implies the roots, you can write the roots are undefined or the roots are imaginary. Either this or this is sufficient. Now question number 4, you are given x squared positive 2 times root of 5x negative 3 is equal to 0. Write the quadratic equation ax squared positive bx positive c is equal to 0. From here a is 1, b is 2 times root 5 and c is negative 3. Now find out the value of the discriminant. So d is equal to b squared negative 4 times ac. My b is 2 times root 5 squared negative 4, a is 1 and c is negative 3. I square this, I get 4 times 5. Negative negative will become positive. 4 times 3 is 12. 4 5s are 20, added with 12 will give me 32, which is greater than 0. So since d is greater than 0, the roots are real and unequal. Okay, that's an important point. Now question number 5, x squared negative 8x positive 16 equal to 0. Use ax squared positive bx positive c is equal to 0. A will be 1, b will be negative 8, c will be 16. And find the discriminant. D is b squared negative 4ac, which is negative 8 squared negative 4 times a times 16. This is 8 squared is 64, negative 4 times 16 is 64. 64 negative 64 is 0. So you got d is equal to 0. So you have to make the conclusion. Since d is equal to 0, this means the roots are real and equal. That's a very important statement you'll have to write. So we got one more question to go. So we got x squared negative ax negative b cubed equal to 0. So write down this quadratic equation. Ax squared positive bx positive c equal to 0. So from here a is equal to 1, b is equal to negative a, c is equal to negative b cubed. The discriminant value is b squared negative 4ac, which is negative a raised to the power 2 negative 4 times a times negative negative b cubed. So this is going to be a squared negative negative positive 4b cubed. Now you cannot make clear-cut conclusion. One of the reason you cannot make clear-cut conclusion is the value of b is the power in which b is raised is actually cubic. Okay, so in this question we are left with the tricky part. Okay, the tricky part is depending upon what we get for a and b, the outcome will change. Okay, now let me just show you. Now suppose if I have a is 1 and b is 2. In other words, a and b are always strictly greater than 0, and that a is always greater than b. Okay, if I have a condition like this and a condition where a is always less than b. Okay, a and b are greater than 0, a is always less than b. So this condition is when a is less than b. So when that happens, a is less than b, we get 1 squared positive 4 times of 2 raised to the power 3. This is going to give you 1 positive 4 times 8 would give you 32, which is 33, which is greater than 0. So if a and b are greater than 0 or positive quantities, no matter whether a greater than b or a less than b, the roots, the conclusion will be the roots will always be real and unequal. Okay, because the reason is that it can't be 0, right? For the simple fact is that you got a squared positive, so you are not going to get an output where you will have the quantity to be equal to 0. That's not going to happen because both of them are positive. Now the challenge comes when a comma b are element of real numbers, okay, such that they can be either greater than 0 or less than 0. So a comma b can be greater than 0, we've already seen. Imagine if they are less than 0, then the challenge comes to us, because if a and b can be negative, imagine we are taking a negative value, say a is equal to say minus 5 and b to be as say minus 3. Okay, clearly in this case a and b are negative but b is greater than a. So if I'm going to take this values, take the square, a squared positive 4b cubed, if I'm going to place negative 5 here raised to the power 2 and add it with positive 4 times negative 3 raised to the power 3, then this is always going to be positive. Okay, this is always going to be positive. This positive quantity is going to give me 25, but this is 3 3s are 9, 9 times 3 is 27, 27 multiplied with 4, 7 4s are 28, 2, 4 times 2, 8, 9, 10, 108. So you're getting a negative 108, so which will be less than 0. The outcome is less than 0. So the condition is when a and b becomes less than 0, the outcome will be depending upon the values that we choose. Say for example, if I were to choose a to be as say negative 5, and if I were to choose the value of b to be as negative 1, then negative 5 squared positive 4 times of negative 1, right, raised to the power 3, this is going to give me 25 negative 4, which is a positive value. Okay, so what am I trying to tell you? The conclusion will depend on whether a and b are less than 0. Now when a and b are less than 0, values for which b is really greater than a, very much bigger than a. Okay, we will have to see how they go, because if a and b are element of real numbers, the values that a and b can take are really huge, and to zero it in and make a decision would be a bit challenging. So how do we conclude this? The best way to conclude this is a squared positive 4b cubed will have real roots and unequal in nature if a comma b are greater than 0. Strictly greater than 0, the roots are real and unequal. So I strongly feel this is the best conclusion that we can settle here as far as this question is concerned. Students were given these two questions. We have to solve them by factorization. Okay, so let us see how we can achieve the solution. So consider a squared x squared positive 4ax positive 3 is equal to 0. I can rewrite this as a squared x squared. I'm going to write this as ax positive 3ax positive 3 is equal to 0. I'm going to club 3ax with a squared x squared and rewrite it as a squared x squared positive 3ax positive ax positive 3 is equal to 0. Now I would take ax out, and that would give me ax positive 3. From here I take 1 as a factor, and that would give me ax positive 3 is equal to 0. Now clearly ax positive 3 is a factor. It is taken out, giving me 1 positive, or I can write it as ax positive 1 is equal to 0. So I'm using the space. So clearly ax positive 3 is equal to 0. Now since x is the variable, a is a constant, I can rewrite this as ax is equal to negative 3. From here x is equal to negative 3 divided by a. This is one solution. Okay, now for the next solution you have to write the word or. Ax positive 1 is equal to 0. So from here ax is equal to negative 1. So x is equal to negative 1 divided by a. So this is another solution. Okay, so you can write, so therefore x is equal to negative 3 over a comma negative 1 over a. So this completes the solution for this question. So let's move on for the next question. So we are given this question, x squared negative of s positive t times x positive st is equal to 0. We have to use technique of factorization. So foremost I would rewrite this as x squared negative s times x negative t times x positive s times t is equal to 0. I will club these two together and these two together. By clubbing these two together, I can take x out and rewrite this as x negative s. From here, I can take, say, negative t out. If I were to take negative t out, I would get x negative s. Okay, negative t times x would give me negative tx. Negative t times negative s would give me positive st. So this is equal to 0. Now clearly, I can take x negative s out, and that would give me x negative t equal to 0. Now from algebra we know that if ab is equal to 0, then either a is equal to 0 or b is equal to 0. So this is an important statement that we have to know. Using that, we know that x negative s is equal to 0, which means x is equal to s. You can box this dot, you can box the result, or x negative t is equal to 0, you can write this as x is equal to t. So therefore the solution should be, or the solution set should be, the values of x is s and t. So that is the solution for this particular question. Students, we got two questions. We expected to solve these two questions by using factorization. So foremost, what I would do is I would consider the first question, root of 5 times x squared positive 12x positive 7 root of 5 is equal to 0. Now what I'm going to do is I'm going to split this 12x as 5x and 7x because of the fact that I have a 7 here, and not only that, I've got a root 5 here. So this split would be doing me a lot of good in solving this question. So this is what I have got now. After splitting 12x as 5x and 7x, I've got a new system. Now what I'm going to do is I'm going to take root 5x out. I'm going to club these two together and these two together. I would take root 5x. That would give me x. I've got a positive 5, but this is root 5. So that would mean I need to place a root 5 there, because root 5 times root 5 would give me 5. That has to be multiplied with x, so it's fine. Now over here, what I'm going to do, I'm going to place a positive sign and take 7 out. So that would mean I got a x positive root 5 there. So clearly x positive root 5 is a factor. It can be taken out. And that would mean I've got root 5 times x positive 7 is equal to 0. So from here, x positive root 5 is equal to 0, or root of 5 times x positive 7 is equal to 0. X is equal to root 5 with a negative sign. That will become a solution. Or root of 5 times x is equal to negative 7. So x is equal to negative 7 divided by root 5. That would be another solution. So therefore, the values of x are negative root 5, comma, negative 7 divided by root 5. So these two would be the solutions for this question. Now let us go on to do question number 2. So we are given question number 2 to be as 7 times root of 3 times x squared positive 11x negative 2 times root 3 is equal to 0. Now what I'm going to do, I'm going to split 11x in such a way that I can have 7 as a factor for that split. So the only possibility is to write 11x as 14x negative 3x. Now by doing so, I can club 14x with 7 and club 3x with root 3. So that is my idea. So you need to be aware of such disintegration. So that comes only by practice. So you need to be practicing and more practice. Now I'm taking 7 out. Now if I were to take 7 out, of course I have to take x also out. So this would give me root of 3 times x, because root 3 times x multiplied with 7x would give me 7 times root 3 times x squared. Now 14x, so that can be achieved by placing a 2 there. I take a negative out and I have a root 3 here. So what I'm going to do, I'm going to take root 3 out. Now 3x can be rewritten as root of 3x, right? Because root 3 times root 3 would give me 3. There's x there. So clearly this way of writing works out for us. I have taken a negative sign, so this is going to become positive. Place a 2 and equate it to 0. Clearly root 3 times 2 would give me 2 root 3. Of course the sign is negative, so negative would be there. Now taking the factor root 3x positive 2 times 7x negative root 3, and that has to be equated to 0. Clearly we would get root 3x positive 2 is equal to 0, or 7x negative root 3 is equal to 0. So from here, root 3 times x is equal to negative 2. So x is equal to negative 2 over root 3. This is a solution. Or 7x is equal to root 3 and x is equal to root 3 divided by 7. So this is another solution. So therefore the solution set, or the values of x, would be negative 2 over root 3 comma root 3 over 7. So that completes the solution for this question. Students, we are given two questions. We are expected to find the value of q given that the quadratic equation has equal roots. So the condition for equal roots is that the discriminant d being equal to b squared negative 4ac should be equal to 0. Now clearly from the given equation, we are given 2x squared negative of q negative 3 times x positive 2 is equal to 0. This is given. So from here we know that the value of a is 2, the value of b is negative of q negative 3, and the value of c is 2. Okay, next find out b squared negative 4ac. In this case is going to be negative of q negative 3. This has to be squared followed by negative 4 times a times c is 2 is equal to 0. When you expand this, this is going to be giving you, this is actually negative of q negative 3. So it'll become positive automatically. So you need to just expand q negative 3 whole squared. That would give you q squared negative 6q positive 9 negative 4 times 2 is 8, 8 times 2 is 16 is equal to 0. So from here you get q squared. Now negative 6q cannot be simplified, so retain it as it is, and then you got 9 added with negative 16. So 9 added with negative 16 would give me 7. Negative 7 is equal to 0. So you have a system something like this. So if you were to take the factorization model, negative 7 multiplied with the coefficient of q squared, that was going to be negative 7. Now the coefficient of q is negative 6. Now you have to find two numbers. When you place those two numbers there, the product of those two numbers should give you negative 7. The addition of these two numbers should give you negative 6. So the only two numbers that can achieve that requirement is negative 7 and positive 1. Because negative 7 multiplied with positive 1 would give you negative 7. Negative 7 added with positive 1 would give you negative 6. So the factors are q negative 7 times q positive 1 is equal to 0. So from here q is equal to positive 7 or q is equal to negative 1. So the values of q, therefore the values of q are negative 1 and positive 7. So that completes the results to this question. Now we are given the next question. Let's do that question also. So we have been given that x squared positive q negative 4 of x positive q is equal to 0. They have equal roots. They have equal roots. Now because they have equal roots, this means the discriminant should be equal to 0. So what we need to do is we need to find the value of a, the value of b, and the value of c, and then substitute them in b squared negative 4ac. So therefore b squared negative 4ac is equal to q negative 4 raised to the power 2 negative 4 times a times c is q, and we need to equate this quantity to 0. So expanding this would give us q squared negative 8q positive 16 negative 4 times q is equal to 0. This can be further rewritten as q squared negative 8q. In fact 8q and 4q can be added, so we would now have q squared negative 12q positive 16 is equal to 0. So this is what we have got. So now the question is to solve this. Now the only way we can solve it for now is by using the quadratic formula. So that would be using q to be equal to negative b plus or minus square root of b squared negative 4ac divided by 2 times a. So from here, if I were to take the value of A to be as 1, the value of B to be as negative 12, and the value of C to be as 16, and then substitute them in the formula, I would get negative of negative 12 plus or minus root of 12 squared. Of course, negative sign doesn't matter because it's a square there. Negative 4 times A is 1 and C is 16. So that has to be divided by 2 times A. So if you were to simplify this, you would get 12 plus or minus root of 12 squared is 144 negative 4 times 16, 6 4s are 24, 2, 4 1s are 4, 5, 6, 64 divided by 2. So you have 144 and you have to subtract 64. That will give you 0. And you have 14 and 6. So that's going to be 8. Okay, 80. So you got Q value to be as 12 plus or minus root of 80 divided by 2. Now 80 can be rewritten as 4 times 20, right? So I want to show you here. 80, root of 80 can be written as 4 times 20, but 20 can be written as 4 times 5. So you got 4 squared there. So if you were to take the square root, you would get 4 times root 5. So this is what you would get. So if I were to place that, this is going to be 12 positive and negative 4 times root 5 divided by 2. Now if you were to take the common factor as 4, then this is going to be 4 of 3 positive and negative root of 5 divided by 2. Okay, 4 times 3 is 12, 4 times root 5 is 4 root 5. Now 2 can divide 4 2 times. Okay, so I can write the solution as, so therefore the value of Q for the quadratic equation that is required to have equal roots is 2 of 3 plus or minus root 5. So this will be the solution for this question. Of course, you need to be a little bit adept in making the calculation and the judgment, but that comes with practice. Students, we are expected to solve this question. X divided by x positive 1, positive x positive 1 divided by x is equal to 5 over 7. Now whenever we are given questions like this, you have to be a bit cautious in the simplification part. Now having said that, let's start off. Now clearly the LCM is going to be x positive 1 times x. So that's going to be x multiplied with x positive. Now x and x gets cancelled, so I'm going to get x positive 1 multiplied with x positive 1. So this is what I get when I've taken x positive 1 times x to be the LCM. So on the right, it's going to be 5 divided by 7. So this is going to be x times x is going to be x squared positive, multiply x with x, that's going to be x squared, multiply x with 1, that's going to be x, multiply 1 with x, that's going to be x, multiply 1 with 1, that's going to be 1, divided by x times x positive 1. It doesn't matter whether you write x positive 1 times x or x times x positive 1. And on the right, it's going to be 5 over 7. Now this can be simplified. X squared added with x squared would give me 2x squared. X added with x would give me 2x positive 1 divided by x times of x positive 1 is equal to 5 over 7. Now we cross multiply. When I do that, I get 7 of 2x squared positive 2x positive 1 is equal to 5 of x times x positive 1. So this is what I've got when I cross multiplied. So rewriting that, 7 times 2 would give me 14x squared positive 14x positive 7 is equal to 5 times x of x positive 1. So just to have some level of understanding, I will first expand this x into x positive 1. That's going to be x squared positive x. It can be rewritten as 5 times x squared, positive 5 times x. On the left, it's going to be 14x squared, positive 14x, positive 7. I move all these quantities to the left, and that would mean I now have 14x squared, negative 5x squared. That's one term. And then the other term is 14x, negative 5x. That's the next term. Positive 7 is equal to 0. Now this would give me 9x squared. This would give me 9x. And this would give me 7 equal to 0. Now the best way to do this is by formula method. Okay, by using the formula technique. So from here, a is equal to 9, b is equal to 9, c is equal to 7. Write the formula. X is equal to negative b plus or minus root of b squared negative 4ac divided by 2 times a. That is going to be equal to negative b is 9 plus or minus root of b squared is 9 squared. 9 nines are 81. Negative 4 times my a is 9. My c is 7. I'm writing it down there. Divided by 2 times 9. This is equal to negative 9 plus or minus root of 81 negative. Now 4 times 9, that's 36 multiplied with 7. 7 times 6 is 42. 7 6 are 42. 4 7 3s are 21, 22, 23, 24, 25, 252. So I get 252 divided by 2 times 9 is 18. Now you subtract 81 from this. So that's going to be 1 and 7, 171. So this is giving me negative 9 plus or minus root of negative 171 divided by 18. Now the condition wants you to just find the value of x. So this is the value of x. In fact, if you want, you can write therefore x is equal to negative 9 negative root of negative 171 divided by 18. This is one value, and the other value is negative 9 positive root of negative 171 divided by 18. Of course, this quantity cannot exist, but just for the sake of continuation and consistency, I have placed it. For you, having a quantity which is negative inside the square root, you can outrightly say the roots are undefined. Okay, but as you progress, this is not, in other words, there are ways in which you can solve this. But if they ask you to find the value of x, then these two would indicate the values of x.